Hello class, this is Andres Garcia and I will be talking about optimization application section 2.1. My last name starts with a G, so that is the subject that I will be covering today. For example, here we have a graph showing us a function, and here we have the maximum and we have the minimum. And so the maximum is the point in which the function is at its highest y level, y value, and the local minimum is when the y value is at its lowest. Reasons for finding the maximum and minimum and using the optimization methods for calculus are to understand a graph better and determine what is the best solution or the best method to get the results that a person needs from either a computer which runs a system at a certain speed, and if you're trying to figure out whether or not you need to, for example, how much you need to study for a calculus test, if you want to get a desired grade, you can do a graph and try to figure out where your minimum would be in order to reach a desired y value, which would be directly correlated to the amount of hours that is needed to get the grade desired. Also, another key point that I want to point out is that a local max or min of f can only occur at a critical point. And so here we're shown some critical points. And here are some examples of what a maximum looks like, a minimum, and here's another maximum, another minimum. And so here it's pretty straightforward. So if we have a graph that looks like this would be a maximum. We have a graph that has a U-like shape, this would be the minimum. So we also learned about endpoints, and here it says the local extremes of a function occur at critical points. These are points in the function that we can find by looking about the shape and using the derivative to help us. But if we were looking at a function in a closed interval, the endpoints could be extremes. So it's saying that this could be a minimum and this could be a maximum because it is a closed interval. And so, yeah. Here we have a final example where we have a maximum of 6 here, a minimum of 2 here. We do have to interpret this whole function as one interval, and this function is x cubed minus 6x squared plus 9x plus 2. We do have this function increasing, or we see this function increasing from negative infinity to 1 here, and then we do have it decreasing from 1 to 3. This function also continues to increase from 3 to positive infinity, and we do have a local minimum of 2 here. So the x would be 3 and y would be 2.